again tomorrow by a special grace of find it. Okay, fine. So you collect this list of transactions. So I mean, as you are sending your transaction, I send my own transaction. Another person staying somewhere send his or our own transactions. It goes into a pool. It goes into something we call mempool. Goes into mempool, something like this. It goes into pool. So you have this transaction inside mempool. So but the transactions are not on the, for instance, I want to send 1 naira or 1 Bitcoin to my friend. That transactions will not just go directly to my client. I mean, to the intended recipient. It goes into the mempool first. Then the miners, their own job is to go to this mempool, okay, and take transactions. Okay, they can at times they decide to take the entire transactions. At times they take lesser number of transactions, depending on one key thing there that we are going to discuss when we get there. So, but what I want us to take out from here is that the miner goes to the mempool, they pull the transaction from the mempool and add this transaction. Okay, they put this transaction on the block, and once they put the transaction on the block, before they can now add the block to the network, there are certain calculations that they have to do. So they have to do certain calculations through their system for them to be able to put this block to the network. So for instance, if you look at the block that I have here, it's having something we call nonce. So that is what they have to look out for. So for instance, after adding all these transactions to the block, immediately this block will create the hash of all the entire transaction. Don't forget that each transaction has its own hash. Then this entire block also will now have a single hash. And don't forget, the hash is used for what? We want to ensure that no form of modification is to repel any form of modification on the network, on the blockchain. So there will be a single hash for this entire block. But the problem is this: the system, the network itself, will create that hash, but append certain numbers, in most cases zeros, to that hash. Let's say this is the hash now. It will now append what? Zeros to the hash. So the job of the miner now, for instance, is to look for a way, what will be the value, a nonce value. We'll see the reason why we have to use that nonce value when we go back to life. Now, what nonce value will give me the hash? Okay, don't forget the system has created the hash already, and the system will append some numbers of zeros to that specific hash. So it's something like this, for instance. Let me show it to you. If you look at this one closely, so this is the block number, block one. Let's say this is the data. The data presently now is empty. We don't have anything inside this block. And as I mentioned earlier, the block will contain lists of transactions, either one transaction, two transactions, or multiple transactions, or even zero transaction. So let's assume that our block presently is containing zero transaction. So as it's containing zero transaction, the system has generated hash. That is from this F here. That is the hash for having zero number of transactions. Now, the system has appended 4 zeros to this hash. So what you will do as a miner now, for you to be able to add these transactions to the network, what you will be subjected to do is to look for a value, a nonce value that will append 4 zeros to the hash. And that is where the computation comes in. That is where we require as a very nice system. If you want to be a miner, you need a system that is very, very fast in terms of the RAM size, in terms of the CPU size, or even if you have the money, you can go for GPU. You have to be able to create, because you are not the only person. I said miners. There are several other people that also want to do the calculation as well. And whoever wins the calculation will have a reward, okay, from the network itself. So for instance, now, all you will begin to do as a miner is to start changing this value. So you put 1, you put 2, and see whether with the hash, those 4 zeros will be added to it. So for instance, if I put 2, it changes the hash, but there are no 4 zeros. If I put 3, no. If I put 4, no. If I put 5, no. If I put 6, no. So you continue to check this value until you are able to get the right nonce value. And once you get this right nonce value, if you are the first person to get it, you quickly communicate back to the network that I've gotten the nonce value, this is the nonce value. Then all other miners on the network will now verify that that nonce value, is it really accurate? If the nonce value is accurate, you get the reward. So we don't just add the transactions directly to the network. So you have this FA computation, ongoing, um, under the hood, for you to be able to do what? To add, for the miners to be able to add transactions to the block of transactions to the network. And of course, this is one way to actually agree on adding block of transactions to the network. We have other ways, okay, to add transactions to the network. This way that uses this nonce value of a thing, that does this FA calculation, is a consensus algorithm that we call proof of work consensus algorithm. The proof of work consensus algorithm. The proof of work, your proof of work, for you to be able to add this block of transactions to the network, is that nonce value that you are able to calculate. And immediately you get the nonce value, then you can mine. You mine the block. Mining the block is just adding the block to the network. And immediately you add that block to the network, whatever transactions you have inside that block will be executed immediately, because the transactions have been verified, the block has been verified, and the transactions can be executed. And whatever money you want to send from one point to the other, the account of the intended recipient can be credited. So this is how we normally generate transactions. It usually start from the transaction itself, that data that you want to send. Then once you send it, it goes into the mempool. And from the mempool, the miners go to the mempool. They collect these transactions, put it in a block. And then they put it in a block, then the network does one thing. The network would say, I need a proof of work from you for you to be able to add this specific net block to the network. We want you to perform certain calculations for us. So, and that calculation will be to look for the nonce value that will generate, it will give you the hash value and the number of zero that is expected of you to generate. So we have a very nice system, a very, very fast